how do you tell the distance to the stars, and how can the Earth be 6,000 years old and the stars be so far away? Fair question. Stephen Hawking said, stars are so far away, they appear to be just pinpoints of light. We cannot see their size or shape. How do we tell different types of stars apart? For the vast majority, there's only one thing we can see, and that is the color of their light. If you get the biggest telescope on Earth, this is not it, by the way, spotting scope, but if you get the largest telescope on Earth and look at the closest star, which is Alpha Centauri, 4.5 light years away, all you're going to see is a dot. If I focus this in on the sun, it'll start to get bigger and bigger, and you can actually see flames leaping off and see the spicules, and you can see color changes, and you can actually see features of the sun. When you look at a star, you never get to see that. Nobody has ever seen a star as far as any of the features of it. You get the biggest telescope on Earth, it's going to be nothing but a dot in your scope. All you can tell is, I say, that's a red one, that's a yellow one, that's a blue one. That's all you can see. So anything we do, we have to do based on assumptions just from the color. But how do you tell the distance to the star? Well, I taught high school trig for years, and if you guys had trig, you know how it works. If you have 2 observation points, you can calculate the third distance. You have to know it's solving a triangle. Trigonometry deals with triangles, so you sine, cosine, tangent. If you know one distance and 2 angles, or two distances and 1 angle, you can calculate the rest of the triangle using sine, cosine, tangent. Here's the problem. Earth is only 8,000 miles in diameter, which compared to star distance is 0. It's nothing. So if I'm looking at a star and somebody over in China is looking at a star, we are 8,000 miles away from each other, straight line through the Earth. That would be nothing. What they've done to enlarge the distance to look at a star, instead of just being opposite sides of the Earth is also going around the sun in this great big huge circle. We're going 66,000 miles an hour, and it takes us a year to go around. Great big racetrack. Well, the distance from the Earth to the sun is about 93 million miles, average. And that's a lot, but at the speed of light, it's not much. At the speed of light, it's 8 minutes away. It takes the sunlight 8 minutes to get to the Earth. So if we're 8 light minutes from the sun, the diameter of our orbit going around is 16 light minutes. So what we're going to do is we're going to look at a star in January, and then we're going to look at the star in June, and we have now gone halfway around this monster circle. And we're going to get 2 observation points to try to enlarge the base of our triangle. And it sounds huge. Man, that's 186 million miles. Well, it's still not much. A year has 525,000 minutes in a year. If this picture here showing the little yellow dot was the scale, if that yellow dot represented Earth's orbit, not the Earth's diameter, the orbit of the Earth, it's way too big for the picture. What we're going to do is try to show you the math involved here. If I had 2 surveyors setting up with their transits or telescopes, and they are 16 inches away from each other, and they're both looking at a dot 525,000 inches away, which is 8 1/3 miles. Would you agree that would make a rather skinny triangle? Let's go out in the parking lot and draw a triangle with point A and point B 16 inches apart, and point C 8 1/3 miles away. It's going to make a real skinny triangle. That is exactly the triangle you get when 2 people on opposite sides of Earth's orbit try to measure 1 light year. 1. Now, and I'm not sure you can tell exactly where you were 6 months ago. I think that would be a little stretch of the imagination to say, oh yeah, 6 months ago in January we were, where were we? I'll give them that. I won't even argue that. I just would bring that up, for appeal, Your Honor, in case we need to. You can't know exactly where you were 6 months ago. But the angle you get with that is 0.017 degrees. Now let's imagine this. I want you to get 2 guys to set up their surveying transits. They're 16 inches apart, and I'm going to go put a dot 8 1/3 miles away, but they don't know how far away it is. They're both focusing in on the dot, and they see this dot out there. Here's the only information they have. The measurement between themselves, 16 inches, and the angle out of parallel. I say, guys, I want you to calculate how far away that dot is based on that little angle change you get. I think that would be difficult to measure. 1 light year. There'd be some guesswork involved, okay? Now if you want to measure 100 light years, you got a much worse problem. Now you got to move your dot 830 miles away. If we had two guys on the roof of this building here in Pensacola, Florida, 16 inches apart, and they're both focusing on a dot in Chicago, which is 830 miles away, but they don't know how far away it is, they're going to tell me how far away it is, based only on their angle of their telescope out of parallel. I would say that's impossible. Impossible. To measure 15 billion, no question that's impossible. I don't think you can measure 100 light years. Not with real numbers, not with real measurements, but this textbook says they can measure, parallax trigonometry can measure up to 100 light years. Okay, I doubt it, but I'll give them 100. I'll give them 1,000 if they quit crying, okay? The fact is you can't measure a billion. Simple fact. So here's some things to consider about starlight. It said in 2004 that the new SIM technology, Space Interferometry Mission, they hope to get where they can improve the distance of measuring to stars. And they say this accuracy will enable SIM to determine stellar distances to 10% accuracy out to a distance of 482,000 million miles. That's 82,000 light years. And then it says, this is an improvement of several hundred times over what is possible today. Well, now wait a minute. If they're going to improve it several hundred times, and it ends up being 82,000, what's 82,000 divided by several hundred comes out to be several hundred. Apparently they're admitting they can only measure several hundred light years, which I would agree. I mean, I would say that's even a stretch, but I'll give them several hundred. They can't measure billions, is the point. So when you students in school get taught, oh, that star's 14.629 billion light years away, I don't believe you. I don't believe you at all. It might be, but you can't prove that. They're making up a story. With SIM technology, they hope to finally be able to get out to where they can measure most of the way across our galaxy, and we're in it. We can't even measure across our own galaxy, let alone these distances to other galaxies. So I think we should look at the stars and say, wow, what a mighty God we serve. Instead of going out there and say, well, we know how far that way it is, we know it evolved. I mean, it's just that egotistical attitude some of these atheists get, makes you want to slap them in the face, like, man, why don't you serve God? Look what he made,